Okay, so I'm just gonna do this ratio test problem real quick because this one with the simplification, if you don't know what's happening, then you can really get lost. And then at the end, there's an extra step you have to do. It's not really clear to you what you have to do unless you've seen it before and seen these type of examples. And I definitely expect to see this on a Winfield test, so I just wanted to like have a video of like step by step because this was on the ratio test like examples that I posted, but I didn't really go step by step and all the steps. I kind of like just simplified stuff without an explanation, so I'm just gonna go over that and here. So for this one, we're obviously gonna use the ratio test, so that would be your limit as n approaches infinity of it's a sub n divided by n, or a sub n plus 1 divided by a sub n, but this is a fraction, so it's not going to be divided by a sub n, it's going to be multiplied by the reciprocal of a sub n. So we can do, so our a sub n plus 1 would be n plus 1 raised to the n plus 1 over n plus 1 factorial multiplied by the reciprocal of n factorial over n. So that's our limit. Basically, for the simplification that happens here is n plus 1 raised to the n plus 1. We can write that as n plus 1 raised to the n times n plus 1 raised to the 1. This is equal to, because since they're like bases, you can just add the powers. So n plus 1 and then the powers of n and 1, you add them together and you get n to the 1 raised to the n to the 1. So our second simplification is going to be of n plus 1 factorial, and that's actually equal to n plus 1 times n factorial. So a really quick demonstration of this, of why that's equal to, because so let's say we have n equals 7. So if we plug that into this like formula we derived, so that would be 8 times 7 factorial, and as we can see here, this is our n plus 1 and this is our n factorial, and so if you multiply those two together, you just get n plus 1 times n factorial, which is what we have there. So I'm gonna plug these in. So the limit as n approaches infinity of absolute value of n plus 1 raised to the n times n plus 1 raised to the first over n plus 1 times n factorial over n raised to the n. So cancellation occurs, you have this n plus 1, n factorial, so you'd have the limit as n approaches infinity of absolute value of n plus 1 raised to the n over n. So I'm going to go on to the second page here. We can actually reduce this into the limit as n approaches infinity of n plus 1 over n raised to the n absolute value. Since they both have the same exponent, you can just write it as one big fraction raised to the same exponent. And for a simplification, we can do divide everything by n, since there's only one term on the denominator, so that would be absolute value of n plus n, or n divided by n plus 1 divided by n raised to the n, and this would be equal to the limit as n approaches infinity of absolute value of 1 plus 1 over n raised to the n. Okay, so if we evaluate this now, 1 over n as n approaches infinity, that's just 0. So you'd have 1 plus 0 raised to the infinity, which is 1 raised to the infinity. The thing is, this is a type of indeterminate form of power raised to the infinity, so we have to do more work here. We just we can't conclude anything with that, so we have to do more work. And this is where the main part I was talking about, how if you don't know what to do here since you've never seen it before, then you're just gonna get stuck. So we're gonna set y equal to limit as n approaches infinity of absolute value of 1 plus 1 over n raised to the n. The next step we're gonna do here is we're gonna take the natural log of both sides. So So once you take the natural log, you can actually take this power and bring it out front. So natural log is equal to limit as n approaches infinity of n times ln of 1 plus 1 over n. And a quick side note, for the simplification, n can be written as 1 over n. This is the same thing because if you divided by this, you'd be multiplying by the reciprocal. So those are equivalent statements. So I'm going to replace the n with this green part over here. So we'd have ln of y is equal to the limit as n approaches infinity of 1 plus 1 over n over 1 over n. So if we do that right now, if we plug in infinity, we do get an indeterminate form. So what we can do right now is use L'Hopital's rule. So L'Hopital's rule, that's what LH is. So that would be the limit as n approaches infinity. This, or I forgot the natural log here, but that would be 1 over 1 plus n multiplied by the derivative of the inside. Derivative of 1 over n is negative 1 over n squared. So that would be negative 1 over n squared over 1 plus 1 over n over the derivative of the bottom is negative 1 over n squared again. So you'd have all of this. And basically what we could do now on the next page, negative 1 over n squared over 1 plus 1 over n over negative 1 over n squared. We can multiply this by negative n squared and multiply this by negative n squared. And so what you would get is this would turn into the limit as n approaches infinity of 1 over 1 over 1 plus 1 over n over 1. And now if we plug infinity here, this would actually be 1 over 1 plus 1 over the n over 1. You would actually get this bottom, this 1 plus 1 over the n, that would just be 1 over infinity, which is 0, plus 1, which is 1 over 1, which is 1, and then 1 over 1 again is just 1. So you'd have 1. But the thing here is to remember is y doesn't equal 1. The natural log of y is equal to 1. So what we have to do is we have to raise both sides to e to cancel out this natural log. And so we have y is equal to e. And since e is greater than 1, we can say this series to from 1 to infinity of n raised to the n over n factorial converges. Oh wait, no, not converges. Oops, wrong thing. You can say this diverges since e is greater than 1 by the ratio test. And that would be your final answer for this. Okay, I just wanted to make a video on this because this is probably the hardest ratio problem you'll see, and I definitely could expect Winfield to pull this type of problem. So I just wanted to make a video just to kind of explaining everything step by step, because on the problems I showed, I didn't really explain all the simplification step by step.